Hello and welcome to Edu-Malanga. On this channel, we make free issue tutorial videos for the Matric Mathematics syllabus of South Africa. Today we will be continuing with sigma notation. This will be the last video that we do on this lesson. Sigma notation is the fifth lesson in the first unit of the year, which is patterns, sequences, and series. We will do two more examples on sigma notation. This lesson is important because most of the questions you will see in your tests and in your exams on patterns, sequences, and series, especially when they are asking about series, will be asked in the form of sigma notation. So let's get into the questions. The first question we will answer will be example number 2 because we did example 1 in the previous video. For example 2, we are given the series 4 times 2 to the power of n minus 1, and we are told that the sum of this series from term number 1 to term n is equal to 262,140. Then we are asked to find n. So we're going to solve for n in this question. When we look at this series, we can tell that this is a geometric series because a geometric series comes from a geometric sequence. And how does the geometric sequence look? We have that Tn is equal to a times r to the power of n minus 1. So if we look at this, we have a times r to the power of n minus 1. We can very easily read off what a is and what r is just by looking at the question. Let's write them down. A is equal to 4. And r is equal to 2. So in this question we are asked to solve for n. We're going to use the formula for summing n terms of a geometric series. Let's recall this formula. We have that Sn is equal to a times open brackets r to the power of n minus 1, close your brackets, divided by r minus 1. We know what a is and we know what r is because we read it from the series when we were given. We're now trying to solve for n. So let's substitute into this formula and do the solution. Sn, because we still don't know what n is equal to, we know a is equal to 4 and r is equal to 2. So we will then have 4 times open brackets 2 to the power of n minus 1, close the brackets, divided by 2 minus 1. This is nice and easy. 2 minus 1 is equal to 1. So we will then only have 4 times, open brackets, 2 to the power of n minus 1, and close the brackets. Let's come back to the question. We are told that the sum is equal to 262,140. So we can substitute where we are seeing Sn. 262,140 is equal to 4 times 2, open brackets, to the power of n minus 1. This is the equation that we're going to have to solve in order to find out what n is. We'll start by dividing by 4 on both sides. Let's divide by 4 over here, divide by 4 over here as well. These 4's will cancel out. If you use your calculator to calculate 262,140 divided by 4, you get 65,535 should equal to 2 to the power of n minus 1. Let's add 1 on both sides now. So we'll add 1 on this side plus 1. And we'll also add 1 on this side of the equation. We will then have 65,536 should equal to 2 to the power of n because these ones will cancel out. In grade 11 you were introduced to logs. I'm going to use logs to solve this question. If you're confused by what I'm doing, please go back to your grade 11 textbook and understand logs because you will find yourself needing them every now and then. So to solve for this, the log function looks like this. You have that n is equal to log to the base of 2, because the base is 2 again, of 65 2,536. If you put this into your calculator, the answer that you will get is that n is equal to 16. And so there you have it. We have solved for n for this series when the sum of the terms is equal to 262,140. Let's move on now to example number 3. In example 3, we're asked to find the sum from the first term to infinity of this series over here. Again, we know we're looking at a geometric series, and we know as well that the geometric series that we're looking at converges because we're asked to sum it to infinity. Let's remind ourselves of the formula for summing a converging geometric series to infinity. It looks like this. We have that sum to infinity is equal to a divided by 1 minus r. That's pretty easy and simple, right? So all we need to do is find out what a is and what r is, and we can read it off again. The question, our a will be 7 and our r is 1 over 3. So we get a is 7, r is 1 over 3, and let's substitute it into this equation. We then have sum to infinity is equal to 7 divided by 1 minus 1 over 3. 1 minus 1 over 3 leaves you with 2 over 3, so we will then rewrite what we get as 7 divided by 2 over 3. Remember, when you're dividing, what you do is you simply swap the numerator and the denominator and then change the sign to a multiplication. We then have sum to infinity is equal to 7 times 3 over 2, and that's equal to 7 times 3 is 7, 14, 21. So you get 21 over 2, and that is the sum to infinity of this series over here. Thank you very much for joining us in this video today. I hope you were able to understand and follow in the examples. If anything confuses you, please practice more or go back to watch the other videos on this channel where we look at geometric series, we look at the sum to infinity of geometric series. Join us again in the next video. We're going to introduce one more series, which is a quadratic series.